Take a look at theoretical probability today. And as we're going to go through theoretical probability, it's probably important that we do a little bit of warm-up exercise and quickly review what we had done for experimental probability. So what we see here in our warm-up is an example of a coin experiment where you have a bag of coins, and they're all different types of coins that are randomly distributed inside different varieties that we have here in Canada. And so one at a time, Johnny picks out 20 coins, and he adds them to his piggy bank and records results shown on the table, because that's the fun thing kind of thing to do. So we're going to find out the experimental probability of these particular solutions here. So we notice here in our table we've got the coins. Okay, so these are the possible results that you would get if you're pulling coins out of a bag. Okay, the frequency, so these are possible outcomes, okay, that you could actually end up with if you're pulling out a coin. You can either pull out a nickel, a dime, a quarter, or a loonie. Those are your options. Okay, the frequency is the number of times, again, that you pull out that particular type of coin. Okay, so the number of, whoops, let's try that again. The number of times, okay, that you get that particular result. Okay, so we know that there's a bunch of coins in there. So let's first figure out, well, what's the total frequency that has been pulled. So again, it tells us he picks out 20 coins. So let's just verify that. So 2 plus 8 is 10, and 6 and 4 makes 10. So for a grand total of 20 coins. So we know that our total result is going to be 20. So we want to first figure out this section right here. So what is the probability of pulling out a nickel? So that P and then in brackets nickel means what's the probability of him pulling out a nickel? So if we look at our chart, we see that nickels, he pulled a nickel out 2 times. So if we want to figure out the probability of picking out a nickel, we need to take a look at, he had 2 results, two results that ended up of him pulling out a nickel out of 20. Okay, and so we've got our fraction. So 2 out of 20 times he pulls out a nickel. We want to also make sure that we can keep this fraction in lowest terms. So both 2 and 20 are even numbers. That means they're both divisible by 2. So we're going to divide both the top and the bottom number by 2 in order to figure out this fraction in lowest terms. So if I take 2 divided by 2, I get 1, and 20 divided by 2, I get 10. So the fraction in lowest terms is 1/10. Okay, now I can also do that as a decimal. Okay, so if I do 1 divided by 10, that is 0.1. And if I want to convert that into a percentage, I would take my decimal and I'd multiply it by 100, and that would give me 10%. So 10% of the time, Johnny happens to pull out a nickel from this particular bag. So next thing that we're going to take a look at here is what's the probability of him pulling out a dime or a quarter. Okay, so again, the word or means you can have either one of these particular results. It doesn't matter which one, but you can pull out either one of the results, and that's what we're going to measure. So if we look at dimes, he pulled out a dime 6 times, and he pulled out a quarter 4 times. So he had 6 dimes plus 4 quarters, okay, for a grand total of 10 pulls that resulted in either one of those two things, in either a dime or a quarter. So in total, 10 out of 20 results resulted in either a dime or a quarter being pulled out of the bag. Again, we have to convert this into lowest terms. Both 10 and 20 are both divisible by 10. So I'm going to divide both the top number and the bottom number by 10. 10 divided by 10 is 1. 20 divided by 10 is 2. Okay, so as a fraction, in lowest terms, 10 over 20 is equivalent to 1/2. We can also put this into a decimal by taking 1 divided by 2, and that would give us 0.5. And if we want to convert that into a percentage, we would take our decimal value and multiply it by 100. So 0.5 times 100 happens to be 50%. Okay. Now, if we're going to carry on, let's take a look here if you want to pull out both a loonie and a dime on a single pull, well, how many times can you pull out a loonie and a dime on a single pull? And this is a little bit of a, not so much a trick question, but this is one where you definitely have to make sure that you read over the whole question. You'll notice that in the question it says that Johnny only pulls out coins one at a time. So if he only pulls out coins one at a time, is it possible to pull out both a loonie and a dime at the same time? Well, no, because then he'd be pulling out two coins at the same time. So the number of times that actually happens is 0. So 0 times out of 20, he pulls out both a loonie and a dime at the same time. So 0 out of 20, if you really want to move it into lowest terms, the same thing as 0 over 1. And if we want to convert that into a decimal, it's very easy, 0.0. And if you want to convert it into a percentage, 0 times 100 gives you 0%. The last one that we'll take a look at here is what's the probability of pulling out not a dime? Okay, so any other coin that is not a dime is what we're going to try and pull out. So we notice that we have dimes, and there are 6 dimes that he has pulled out. Okay, now if he pulls out not a dime, that means he could pull out either a nickel, a quarter, or a loonie. Okay, so again, there's 2 ways to do that. We know that there's a total of 20 pulls in total, and we know that there are 6 dimes. So if I do 20 minus 6, that means the other 14 results all end up being something other than a dime, either a nickel, a quarter, or a loonie. We could also take a look at looking this in a more indirect way, or a more direct way. We can add up the other options. So I know he pulls out 2 nickels plus 4 quarters plus 8 loonies. Okay, and that should also give me a result of 14. So whether you subtract the number of dimes or you add up the number of nickels, quarters, and loonie pulls, you will still get 14 out of 20. So if we know then that 14 out of the 20 results is not a dime, we can put that as a fraction of 14 over 20. Again, we want to convert this into lowest terms. And so both 14 and 20 are even numbers, which means they're both divisible by 2. So if I divide both the top number and the bottom number by 2, 14 divided by 2 is 7, 20 divided by 2 is 10. So that gives me 7 out of 10 as a fraction in lowest terms. If I want to convert this into a decimal, I would take 7 divided by 10. And so as a decimal, it's 0.7. And then if I want to finally convert that into a percentage, I would take 0.7, multiply it by 100, and that would result in 70%. So just a quick review of experimental probability there. Again, we talked about determining probability using or, probability using and, as well as using direct and indirect methods of counting.